Welcome all. We are here to present database implementation for a shipment dispatching trip planning system. The presentation covers following topics: a brief explanation of shipment dispatching process, an overview of data tables for the system and their creation, an example to illustrate the utility of database implemented here, and last, we'll show how the database can be used for making strategic decisions. So let's understand what actually is shipment dispatching and how it works. Shipment dispatching is the process of deciding the sequence of trains each shipment takes from its origin to destination from each yard. Now let's see the cycle which a shipment undergoes starting from its origin up to it reaches its final destination. In railroads, an incoming shipment is called a waybill. Now, when a waybill enters into the system, it is assigned to a sequence of blocks in which it will travel from origin yard to destination yard. A block in this context is basically a group of waybills that travels together between two stations. As we can see here, waybill WB is assigned to three blocks B1, B2, B3 to travel from origin O to destination D. As there are three blocks in entire trip, hence logically there exist two intermediate stations between yard O and destination D. Block B1 travels from origin O to intermediate station MS1. Block 2 travels from station MS1 to another station MS2, and finally block 3 travels from intermediate station MS2 to final destination D. Now in the system, each block can take a unique sequence of trains to travel from its respective origin to destination point. For example, block B1 can take different sequence of trains to travel from yard O to intermediate station MS1. Each such sequence is called a block path. In our example, block B1 has only one possible path, while block 2 and block 3 had three possible block paths available to them. This is the representation of showing the block paths. Now, as we mentioned that a block path is basically a unique sequence of trains, hence these block paths constitute of train segments that specify actual train assigned to each block path. In our example, block paths B1 P1, B2 P1, B2 P2 and B2 P3 has single train segments, but block paths B3 P1, B3 P2 and B3 P3, there are three trains assigned to each path to cover between MS2 and destination D. So here you can see that these are the mid stop or mid station, and these four are the train segment for these block paths. Hence, to summarize here, waybill WB is shipped from origin O to destination D in three blocks. Each block has choices of block paths to choose and sequence of trains to be assigned. The decision is taken based on arrival and departure time of blocks and trains. Now let's see how we create database to incorporate data to implement the entire shipment dispatching system. We created following 6 tables to include all required data. First, the table waybill, which consists of all details about each waybill for which trip is to be planned. Next is waybills to block, which specify assignment of blocks to each waybill. It's a connecting table between waybill and blocks in system. The third table is block in system, having details of all the blocks existing in the system. Next is block path table that has data about unique sequence of trains for each block. Next one is the block to train assigned table that comprises of all train segments existing for a particular block. And finally, we have train segment table consisting of actual trains and their details like capacity scheduled for a train segment. Here is the ER diagram for the system. So we have many-to-many relationship between variable table and variables to block, and again many-to-many relationship between variables to block table and blocks in system. Then we have one-to-many relationship between blocks in system table and blocks path, and then many-to-many relationship between blocks path and block to train assign, and train segment and block to train assign. Now this is the create table command for creating table variables. These are the column names, field names, and we have two constraints on this table. The one is the operation check, which determines that operation time can be the switch or the swap, and we have primary key constraint on column variable ID. This is a screenshot of the variable tables which got created. Similarly, next we have create table command for variables to block table, and there's a screenshot for the table created. Here we have composite key on variable ID and block ID. So these are primary key and foreign key. Next comes the block in tables, where we have block ID as the primary key, and here's the screenshot of the table created. Similarly, we have create table command for blocks path. So here block path ID is the primary key and block ID is the foreign key, and there's a screenshot of all the columns that are created with their data type and other fields. Again, similar create table command for train segment, and here we have train segment ID as the primary key, the only constant that we have in train segment table. Lastly, this is the create table command for block to train assign table. Here we have block path ID as the primary key, whereas train segment ID is the foreign key, which is reference to train segment table. There's a screenshot of the table created. Now in next section, we will show how we query database to extract information in order to decide train sequence to ship a particular variable. We have selected a variable with variable ID this one. In order to extract details about this variable, we fired a select command on table variable, filtering by this variable ID. The result of query is shown here. This specifies that variable arrives at Denver on 15th October 2010 at 6:32 a.m. and it needs to be transported to its destination yard, Pasadena. Next step is to find blocks to which this variable is assigned to and details of those blocks. For this, we fired select query on table variables to block, joining with table variables, and filtered it with by variable ID, for which we need to find the shipment plan. The result shows that variable is assigned to 3 blocks: block 78, block 1421, and block 1685. Now, block level information is stored in table blocks in system. Firing query on this table and filtering it by variable ID gives details for each block. For example, as we can see here, block 78 travels from Denver to MS Yard, block 1685 travels from MS Yard to Teague, and block 1421 travels from Teague to Pasadena. Now we need to find the exact block paths which are taken up by blocks 78, 1421 and 1685. For this, we fired query on table blocks path and joining it with blocks in system and variables to block to filter it by block ID and the variable ID. This is the result of the query fired. So we can see here that for block 1421 there are possible 3 block paths: 17184, 17185 and 17186. For block ID 1685, we have another 3 block paths with these IDs, but for block 78 we have just 1 block path ID. Here is the diagrammatic view of all the informations that we have fetched till now. Now this shows that from origin Denver to Pasadena, we have 2 mid station, MS Yard and Teague. Between Denver and MS Yard, block ID 78 is transported through single block path. Between MS Yard to Teague, block ID 1685 can be transported through 3 block paths, and similarly goes for block ID 1421, which has 3 block paths running from T to Pasadena. Next step in the process is to determine train segments for each block path. This information is extracted from table blocks to train assigned. Now firstly we have found the total number of train segments for each block path. As we can see from here, one train segment each for block path ID 796, 17184, 17185, 17186, and there are 4 train segments for each of block path IDs 20274, 20275 and 20276. Next we have fetched exact train segment IDs assigned to these block paths, and this is extracted from table block to train assigned, and they're filtered by the block path IDs that we have extracted from previous slide. And here is the summary of all the train segments, unique train segment that is assigned to these block paths. So this is the diagrammatic representation showing the train segments for each block paths. So we can see here that between station T and Pasadena there are 3 block paths, and each block path has 3 mid stations, that is intermediate stations, which constitute of 4 train segments. Now this shows that there can be a single train that runs from T to Pasadena, stopping at these 3 intermediate yards, or there may be 3 different trains connecting T to this intermediate station and further until it reaches Pasadena. Now the last step to fetch the actual trains that runs through these intermediate stations and from origin to destination through these block paths are extracted from table train segment. So this is a select query where we have filtered it through the train segment IDs which we have fetched in the previous step, and this is the result of the query fire. Now we can see here that from our origin Denver to the intermediate station MSR there is a single train running. Then from MSCR to the another intermediate station T, we have these 3 possible block paths, and among these possible block paths these are the 4 segments, which shows that the same train is running between MSCR to T, but there are 3 further halts, that is Quanah, Wyckoff, Texas and Nair FTW. Similarly goes for these 2 block paths as well. Now connecting from T to Pasadena we have 3 different block paths, but there is a single train segment for each block path. So till now we have seen that how we can query our database to fetch information at each level in the entire shipment dispatching process. That information could be Weibel level, block path level or train segment level. But there is more use to this database implementation. We can create certain reports which can be used by yard manager to take certain strategic decisions in planning and management. In our presentation, we have shown such 3 reports, the SQL queries and the final report screenshot that was generated from Oracle. Our first report generates all the data which is required for planning a trip for a particular Weibel. Now these are the inputs that a yard manager requires in the report to take for taking shipment dispatching decisions. First one is blocks to which Weibel is assigned, another one is all possible block paths that a block can take, and the third one is all possible train segments and schedules for dispatching the blocks. This is the query for generating this report. So we have created several views and fired a select query command to generate the reports, fetching all the required data. The resultant report generated is shown in 3 parts here due to space crunch. First part consists of Weibel level details, that is the Weibel that needs to be shipped, its origin yard, its destination yard and its arrival date and time at its origin. Next consists of block level details, which consist of the blocks which is assigned to the Weibel, its block path IDs, and block level details which constitute of its origin, destination and its schedule timings. Last, it's a train level details that is all the actual trains that run between those block paths. Another possible report is to identify stations with maximum traffic. By querying table labels, we found MSCR to receive maximum shipments. Now, this information can be used to plan additional resources for such stations. The last report that we generated is to find capacity of outgoing trains from each yard. With this report, we could find stations with maximum and minimum capacity and use this information to utilize excess capacity yards for fulfilling demands. So like these, the database can be further used to extract many more informations and insights to plan and manage shipment dispatching systems.